Hey everybody, it's Mrs. C, and I am coming to you with a little bit of a, let's say maybe an overview of how exactly do you do something that we've been doing in class in a practical sense. So what I'm saying is we've been plotting points, connecting those points with straight lines, and then been trying to figure out how could we come up with an equation for the line that we've drawn. So say, for example, we start here with a point A, we'll say right there, and a point B, we'll say right there. Let's first start by identifying what are those ordered pairs. So let's say point A appears to be at what's that, -5, 6, 7, 8, and -8, -2. So we have point A at a -8, -2, and you guys are all in a position here where you do have points, and you're trying to figure out, oh my gosh, how do I make that line fit? So let's just come over here to point B. Appears to be that point B looks like it's at, what is that, 6, and then up to 4. So we're at 6, 4. So we've been using a program called Desmos, and you put the points in, right? And then you manipulate the line to try to get it to fit right in between those 2 points. So say we are using Desmos now. Let me see if I can actually do that there. And Desmos has created a line for us just like that. And what we're going to do now is we take a look in Desmos at what the sliders say. It tells us what the slope is. It tells us what the B, so we know what the M, oh, sorry about that. We know what the M and we know what the B is. So the M and the B. So for those of you that aren't in the middle of the activity that we're doing in class, we are writing equations in y equals mx plus b. And that's a universal formula right there. It's a universal form for the equation of a line in what we call slope-intercept form. And so the first thing we try to do is, on our computer, it gives us decimals, it gives us an idea as what number would go in the M and what number would go in the B. But when we zoom in, we all know it doesn't appear like that. Our line is like right spot on the dots. So in a future video, I'm going to do a Desmos video, but right now I just want to get a little intuition here. How could we actually calculate, looking at a graph, what the M truly is, guys? How would you know without having to use a slider in Desmos what the M or the slope is? Well, slope is a ratio of the change, and we'll use the symbol delta, change in y over the change in x, or also known as delta y over delta x. And all that really means is we have to kind of calculate how much our y coordinate changes from one point to the other. Really very simple if you think about it. So let's take a look at what our change in what our change in y is. So our original y, let's say we started at point A. Makes sense to start at the bottom and move up. So we started at a y coordinate of -2, and we moved to a y coordinate of 4. So what was the change? To go from a -2 to a 4, how far up do you have to go? How far up do you have to go? Well, how many units do you go up? You go up, let's check them off. 1, 2, 3, 4, 5, 6. You go up 6 units. And then that would be our change in y. The change in our y coordinate was 6. Now, how far over would you need to go? That's the next question. So we go up 6, 1, 2, 3, 4, 5, 6. How far over? Well, let's try over. That would be this way. So I have to go over, I'm going to count them, I'm trying to make the mark, 1, 2, 3, 4, 5, 6, 7, 8. By the way, I was at -8, so that makes sense, right? 9, 10, 11, 12, 13, 14. And by the way, that makes sense, right? Because I wound up at 6. So what is 8 plus 6? 8 plus 6 is 14. So 14 would be my change in x. That would give me the ratio of 6/14, 6 over 14 being my rise. Our change in y is a rise. And the change in x is what we refer to as the run. And so you'll also hear slope referred to as rise over run. And really, that's it. I know you're thinking it's got to be more complicated than that. No, not slope. Slope's pretty straightforward. Your change in your y values over your change in your x values gives you your slope. Now, okay, 6/14 isn't simplified. It doesn't have to be. I mean, 6/14 was the actual rise to the run, but is there a more simplified version of that? Yeah, there is. So how do you simplify 6/4? Maybe we could, 6/14, divide everybody by 2. I'll come over here because I'm out of room on that side. That would give me a 3/7. That means that on this line that I drew, the blue line, I could actually go up 3, rise 3, and run 7 and still hit the line. Watch. It's the coolest thing ever. Let me change colors so that you can actually see me do this. I'm going to go up 3. 1, 2, 3, and I'm going to go over 7 and watch me hit the line. 1, 2, 3, 4, 5, 6, boom! Hit the line. Because the line has a simplified slope of 3/7. Any proportional relationship to 3/7, meaning multiply top and bottom by 2, by 3, by 4, it doesn't matter. You'll still hit the line, which is really, really cool. All right. So all that just told me that my actual m, let me come up here, is 3/7. I like a simplified version because it's nicer. But where do I hit the y-axis? That's what your b is. So I want you to take a look at it while I maybe get rid of some of this extra stuff. When you're looking at the line, there's 2 things you want to make note of, really. You want to make note of what your slope is. For example, is it gradual? Is it steep? Is it positive? Is it negative? I picked a slope that was going to be positive, so I wouldn't even have to get into any of the other stuff. But the other thing you need to look at is where does it hit the y-axis? And so now, when I get rid of some of this stuff out of our way, we can really focus in. Maybe we can actually take a look at where does this line hit the y-axis. So can you give me an approximate? Now remember, I'm asking for the y, not the x-axis. It's really where it hits the x doesn't matter so much to me when I'm doing equations. Poor x-axis. Okay, so here's our point A. I'll put it back here. And where does it appear to be hitting the axis? I see it. I'll put a point on it. Give me a second. I'm getting there. Right about there, doesn't it? It appears as if it's hitting at +1. So again, this is all of what it appears to be. If it's hitting at about a +1, that would make my b a 1. And that would make my equation y equals 3/7 x plus 1. But I've just got this curiosity. Is that really 1? I mean, I drew it. Is it 1.1? Is it 1.2? Really hard to tell. So what we have is we have equations that help us get that answer a little bit more clearly. So let's actually clear this bottom section off for a second and take a look at another equation, another form that's going to help you figure out the exact equation of a line given 2 points, given anything really that you would ever be given. You can come up with the actual equation of a line. It's called point-slope form. Now we just dealt with slope-intercept form. That's this one. Point-slope form looks a little bit more intimidating. Don't be intimidated. It's not going to hurt you. It's y minus y1 equals m times the quantity of x minus x1. And simply put, it asks you for one of your ordered pairs to be plugged into the x1, y1 positions, and the slope that you had to have already derived goes into the m. So we already have a slope. Let's go ahead and we'll put that in. I'll use another color. We'll do 3/7. sevenths right there on top of my m. And then do we have an ordered pair? We did. Do you remember? Excuse me. We had a 6, 4 was one of our ordered pairs. Let's go with that one. I like that one. Point A is in the negative quadrant, and so I try to avoid negatives if I can. So let's just plot. X goes into the x1 position right there. Did I say X goes into the 6 goes into the x1 position. 4 goes into the y1 position. Then we just have to copy it so it looks pretty. Y minus 4 equals 3/7 times x minus 6. We will do a little bit of distribution. We'll say y minus 4 equals 3/7 x minus, stay calm, 18/7. You just multiply numerator to numerator, denominator to denominator, and you get 18/7. If you got confused on that, we need to do a little bit, maybe more work in fractions. So then I want to go ahead and add my 4 to both sides. Trying to figure out where I'm going to put 4 in this little mess. And if I could just clean that up, it will be in slope-intercept form. Now I said calm. I'm going to move over here a little bit. I said calm because everybody has a tendency to freak out when they see fractions. So I want you to just be calm. I'm here. I am here. I'm going to come up into this space up here just to give us a little bit more clarity. We have a y equals, right? We have 3/7 x, which is great. We already knew that it was 3/7 x. And by the way, it's all, if you remember, the original equation we came up with is right over here. The question is, when I combine, look back down here, a negative 18 and a positive 4 together, because they're like terms, will I get the value of positive 1? Well, there's only one way to find out. We have to combine a negative 18/7 and a positive 4. So, what is 4 as a 7th? Well, one way you could find, why would I even want to do that? It would be another question. I want to actually combine fractions, which means I need common denominators. So, I'll come up here and I'm going to rewrite just here so we can see the work, a negative 18/7, and I'm going to add 4. But I need to write it as 28/7. That just means I multiplied 4 times 7, put it up at the top as a 28 over 7, and if you did 28 divided by 7, you'd get 4. So if you can't follow that, you can always use a calculator. That can help you. You can just go ahead and do the math that way. So when we do a negative 18 and a positive 28, we've got to subtract, right? We wind up with what? That's right, we wind up with a 10. I'm going to try and put the 10 right there. And you keep your denominator 7. Why did I subtract? Because the signs are different. So when the signs are different, I had a negative here and a positive here. You subtract. You take the sign of the higher number. That was positive. Positive 10/7. So now that's the actual equation of the line. 3/7 x plus 10/7. 10/7, not 1. How close is 10/7 to 1? Well, you can think of it as a mixed number. 7 goes into 10 one whole time with how many left over? 3/7. So it's like a what, 3/7, like a little bit like a half-ish. So it's more like it's more like 1.5 than it is like 1. But that was a pretty good estimate, I have to say. I think I would leave it just like that. You could also write it as 1 3/7. That would be okay. A little bit under at 1.5. That's how you do it. Now that's overwhelming. Believe me, I understand. So let's just come over here for a second. Say you had 2 points. I'm just going to make it up. 2, 4, and say that's point A. And you had a point B. I'll just keep it positive again. 3, 2. How could you write the equation of the line without being able to graph it? You're not always going to have graph paper. You don't even have graph paper in class when you're supposed to have graph paper, for heaven's sakes. You've got to have another way to write an equation of a line, or at least understand what this line would look like as an equation. You use your point slope form. It's really straightforward. Do you remember what it was? It's y minus y1 equals m times the quantity of x minus x1, where your x1, y1 are one of the pairs of the points. And so you pick one pair. There's not one pair better than the other. So let's just pick the first one, 2, 4. We would put the 2 in the x, because 2 is the x, 4 is the y. So you put the 2 in for your x. That's probably the hardest part, is to make sure you put them in the right place. The 4 in for the y1. And then the slope. Oh no, I don't have slope. There's no slope here. So how do you actually find the slope? Well, that's a really good question. You could try to think of the points plotted and then decide what would the rise, what would the run be by visualizing them. But that's really not the best. Sorry, look at me. I'm trying to, let me shut up while I write this. X minus 2. That's really not the best way to calculate slope. We have a formula for calculating slope. I use what we call the arrow method for finding slope. So whichever way you go about calculating slope, this would be the time to do it, because nobody told you the slope. And unless you have it on graph paper, you're not going to be able to know it. Now, of course, you can always throw down a little graph, right? You can plot where your little 2, 4 would be. 2, 1, 2, 3, 4 would be here. And then 3, 1, 2, 3, 2 would be 1, 2, there, right? And then you could calculate what was the rise to run to go from one point to the other. Well, you'd have to rise 2 and run 1. That's a slope of 2 over 1, which is 2. The issue here, though, that makes it a little bit tricky to figure out is that I actually went up, which was a positive move, and to the left, which was a negative move. That gives me a negative 2 slope, because a positive divided by a negative change is going to be negative. So again, remember, it's change in y over the change in x. And my y change was positive, but my x change was negative, and that's why I would wind up having a negative slope. It wouldn't matter if you reversed it and went from the top point to the bottom point. Your change is still going to wind up being negative. Watch. I would have to go down 2. That's a negative. I'm going to write my change in y over change in x up here again. If I go down 2, that's a negative change. Then over to the right, that's towards the positives, that's a positive change. So that also is negative. Whenever you have a negative and a positive combination move, your slope is going to be negative. Those lines, if you look at them, that line going from left to right is actually going down. That's why it's negative. It's kind of cool, isn't it, when you think about it? So there's my slope. My slope is 2. And there's many other videos that I have on how to calculate slope. So if you haven't already come to it, you don't want to draw slope every time you try to find it. So please go watch one of those videos on how easy it is to calculate slope. So you swap in the little negative 2 there, and now you do the math. And isn't it nice to not have to work with fractions? It really, really is. Okay, I'm quite happy. So let's clean this up. We have a y minus 4 equals a negative 2 times x minus 2. And then we just do the work, right? You have a little negative 2x, positive 4, and then bring down the y minus 4. We can go ahead and add that 4. That gives us 8, and that gives us our answer. I'm just going to come over here, clean a little space for myself so that I can write the answer. So once you get it in y equals form, it's the most popular form to write your answer in. That's why I'm writing it in y equals. We have y equals a negative 2x plus 8. And that is what it would look like if it was graphed on a line. Now, even better, y equals negative 2x plus 8. Let's come over here for a second. What if I gave you y equals a negative 2x plus 8? I just drew that. Sorry, I meant to use my line tool. Okay, what if I gave you the equation y equals a negative 2x plus 8? Do you know enough about that equation to graph it on the line? That is a whole nother skill. But with the activity you guys have been doing, you should be able to do that pretty easily, right? You know that the slope is going down, right? Pretend you don't know those points. Nobody gave you the points. All you know is the equation. Well, think about what you know. You know that positive 8 is where it hits the y-axis because that's the b. It's in the b position. The y equals mx plus b. Whoever is your constant is in the b position, meaning it's the constant's position with no variable. That is where you hit the y-axis. So where is 8? 1, 2, 3, 4, 5, 6, 7, 8. It's way up. Excuse me. It's way up here. I think I counted right. 1, 2, 3, 4, 5, 6, 7, 8. Yes. I know I'm going to hit that black dot with this equation. The only other question is, who's in the M position? A negative 2. Now, if you remember how we came up with this, we knew that the negative 2 was a negative change, right? So I either went up and towards the negatives or I went down and towards the positives. Well, I can't go up. I don't have any more room on my screen. So I'm actually going to use the change where I would be going downward. So I'm going to make a change. If my slope is 2, it's a negative 2 over 1. It means that my change in y was a negative 2 and my change in x was 1. So from the point that I already know, I'm going to go down 2. That's my negative move, right? And then I'd have to go to the right 1 because that would be my positive move. So down 2 and over 1 would put me there. And you can repeat it. Go down 2 more and over 1. Go down 2 more and over 1. When you connect those points, you will have, trying to get in there. There it is. Not the best drawn, but you would have your line. And that is that. Listen, guys, thanks for sticking with me. I know this was a long video. There was kind of a lot to cover, and my gosh, there's so much more to cover. So if you're confused at all, please look at my playlist. I've got tons of fun when it comes to graphing slope, slope-intercept, all the different forms, all the different things you can do with these babies. Hope it was helpful. And if not, you know what? I'm going to see you on the flip side anyway. Peace.